Okay, see Lindelof videos, particle motion with your graphing calculator. Anybody who knows me knows that I'm a huge fan of ti-nspire casts. So that's the problem. That's the way we're going to do our problem today. This is from the 2005 Form B AP Calculus AB exam. It says a particle moves along the x-axis so that its velocity, and this is huge to me to keep track of this, so its velocity v at any time for t is greater than or equal to 0 but less than or equal to 5 is given by velocity v of t is equal to ln of t squared minus 3t plus t. So I'm just going to read through the problem a little bit, and then we're going to get straight to the calculator. It says find the acceleration of the particle at time is t. And then I'm just going to read a little bit forward before I decide how I'm going to chase this. It says, is the particle speeding up or slowing down at t equals 4? Explain. So what I'm going to do is this. I'm going to go to my TI. I'm at the calculator screen, and I'm just going to put this function in, this velocity function. I'm going to say it's ln of, and if you don't mind, I'm going to use x because I sometimes graph it, x squared minus 3x plus 3. Control store, and then I'm going to save this as v of x. And if you're wondering if you could save this v of t, you can. That would be fine if you put it in terms of t. I just don't know if it would graph or not, so I'm kind of just trying to get around that. The next thing I'm going to do is this. I'm going to go to my menu screen. So this gives us for our velocity function, and we saved it as velocity. But they're asking us for acceleration, and I looked at part B of the question, and we're going to need to know both. So what I'm going to do now is I'm going to go to my menu here. So I just went to the menu button here. I'm going to choose calculus. From calculus, I'm going to choose derivative. We look up here, and we have this function up here in terms of x, so our derivative will be in terms of x, and I want the derivative of vx. Seems easy enough, so there's that derivative. Now check this out for a second. I'm just going to hit my up cursor for a second, hit that, and then hit enter, and it rewrites the whole thing, and I'm going to put control store here, and I'm going to ask it to save that as a of x. I think this should be making some sense to you now. So the first thing they ask us is, what's a of 4? Isn't that what they wanted? They wanted a of 4, so I'm going to ask that. A of 4. So it gives us 5/7. That's a really good answer. If you don't like that, though, if you would rather put it in decimal form, just hit Control Enter, and it's 0.714. So now I'm going to go back to my problem, and I'm going to put this on, say A. So this is problem A, and that A of 4 is equal to 5/7 is equal to 0.714. And here, if you don't mind, I'm just going to put in this approximation thing right here, right? So that's that. I did problem A. Does B, is the particle speeding down or slowing up? So, and then it says explain. This is really important. So I'm going to go to problem B. Say, okay, B. So we know that A of 4 is greater than 0. Now the question is V of t. So let's see what V of t is. I'm going to go back to the calculator and put in V of 4. So V of 4. Enter ln of 7. That's a positive number, but just if you want to see it, is 1.94. You don't even need to know that. 1.945. Remember that. V of 4 was equal to 1.945. 1.945 is greater than 0. Sine of A of 4 and V of 4 are the same. I didn't say they're positive. It doesn't matter that they're positive. They have to be the same. Are the same. Therefore, speeding up. And there's my answer for B. All right. So I'm going to move on to the second part of the question, but I think I'm going to stop this video here and come back to it and call this part 1 and part 2. So thanks for watching. I hope this was helpful, and I hope you go and watch part 2.